This is the part 2 of the video, that is benzoin condensation. It is condensation of aromatic aldehyde in presence of a base to give you what is known as benzoin. In this KCN it is used. Now let us come to the mechanism. First will be the formation of carbanion followed by the nucleophilic attack. So carbanion, if you see here, benzaldehyde is taken, that is reacting with CN. So this bond will shift here, this will become negative, oxygen will become negative, this carbon will become positive. So this cyanide can now attack carbon, resulting in the formation of this product. Now in this there will be some rearrangement or shifting. This hydrogen, it will move to the oxygen, leaving its electron which will be shifted to carbon, thus forming what is known as the carbanion. Now this carbanion, it will be reacting with the second carbonyl compound as a nucleophile. So this bond will shift here, this will become negative, this carbon will become positive. So this as a nucleophile can attack this carbon. Now here some rearrangements are there within a molecule. So this bond, it will shift here, this will become positive, so it will attack oxygen minus, and this electrons will shift here to stabilize this carbon. As a result we get what is known as benzoin. Let us talk about the reduction reactions. This is Clemmensen reduction, in which you will be taking aldehyde or ketone in presence of zinc amalgam and acidic medium, that will give you the corresponding hydrocarbons. So let us talk about the mechanism. This reduction takes place in acidic conditions. So carbonyl group will be first protonated, as you can see here, and this protonated species will take up electron from the zinc, thus forming this, and that in acid medium it will take two protons, one to this carbon, another to OH, and it will give you this. This is followed by elimination of water molecule. Again carbon will become electron deficient. Now this electron deficient carbon, it will be taking electron from zinc, and then again proton will be taken. This being negative, it will accept proton, resulting in the formation of a hydrocarbon. Now let us talk about Vlkisch Net reduction, that is reduction of aldehyde in presence of hydrazine to give the corresponding alkane. Now this reaction takes place with KOH in presence of ethylene glycol or dimethyl sulfoxide as a solvent. In this case I have taken acetone in presence of hydrazine. So first it will give you hydrazone, which in presence of KOH will give you the corresponding alkane. Let us talk about the mechanism. Hydrazone in presence of OH. Now one hydrogen will be eliminated, so when it goes, it leaves its electron to the nitrogen. So water will be eliminated, this nitrogen will have those electrons, so these electrons will shift here. As a result, these electrons will move to the carbon, making this negative. There will be rearrangement, this being negative. Now this hydrogen will move here, leaving the electrons to the nitrogen. Further, there will be elimination of nitrogen, so these electrons will shift here, making this triple bond. As a result, this electron will shift here, this again carbon will become negative. That in presence of water, this hydrogen will transfer here as positive, so these electrons will shift towards O, so OH will be eliminated. So this will result in the formation of a alkane. This is Marvin-Pondorf-Verley reduction, in which a ketone, it will be reduced to secondary alcohol in presence of isopropyl alcohol and aluminium isopropoxide. Now during the reaction, acetone will be distilled off. When we talk about the mechanism, this is the ketone which we have taken. This is isopropyl alcohol CH3CH3CHOH, and this is aluminium isopropoxide. So this bond will shift. As a result, these electrons, they will be shifted to the carbon. This will become negatively charged, therefore this proton will attach to the carbon. Now in this, when these electrons they shift, this carbon become positively charged. So these electrons, they will shift here, as you can see here, shifting here, and hydrogen will be eliminated as H+. Now when this breaks, this is O negative, so this H, it will be attracted towards O negative. So this will be RCrCHOH, that is the secondary alcohol acetone and this aluminum isopropoxide. So this is Mirwin-Ponndorf-Verley reduction.